So, my name is Daniel, and I'll be doing question 3 for the exam. So, to start off with part A, it asks in an operation, an electric toaster has an RMS current of 3.95 amps. When plugged into a wall socket with RMS voltage 1.2 times 10 to the power of 2 volts, find the toaster's average power. All right. So, let's start off with just drawing a little circuit real quick. All right. And so, real quick, let's just write down what we have. We have an RMS current of 3.95 amps. So, I RMS equals 3.95 amps. Let's just write this is A through C for now. And so, we also have a RMS voltage, so VRMS of pretty much 120 volts. And it's asking to find the average power. So simply to find the average power, all we have to do is use these formulas, which is that the average power is half of the voltage current, which is also equal to voltage over square root of 2. And current over square root of 2, which is also equal to V RMS and I RMS, which is simply just us multiplying the two values we already have. So that'll be that'll be pretty much 120 volts times 3.95 amps, which is equal to 474 watts for A. And now to find the maximum instantaneous power is going to ask for part B. Well, since it's what was it called? A pure resistor, since it's an electric toaster, it means that the pretty much, what was it called? Voltage and current are in phase. And so since they are in phase, pretty much it would be P equals voltage, current, cos square root of 2 WT. And pretty much that's equal to, I guess the maximum of the instantaneous would mean that it's equal to 2 times the power average, because was it P max is equal to voltage current, which is equal to 2 times P average. It would be equal to 2 times P average. So all we really have to do is just multiply our average current, or average power, of 475 watts, 474 watts, times 2, which is equal to 948 watts. 948 watts for part B. 948. And for part C, we just have to find the resistance. And to do that, we use another formula, which is P average is equal to I RMS R, which is the resistance to the power of 2 over here for IRMS. We just have to rewrite it pretty much. So we just put R over here, equal this, and that'll be PAV, average over current, RMS squared, which is just going to be resistance equals, what was it again? 474 watts over 3.95 amps squared, which is equal to 30.38 ohms. So pretty much R equals 30.38 ohms. And so let's move on to part D. This is going to be part D to F. D to F. That'll have an LRC circuit, series circuit, has a source with voltage amplitude of 35 volts and angular frequency of 1.3 times 10 to the power of 3 radians per second. The resistance is 275 ohms. The inductance is 82.3 millihertz, and the capacitance is 1.10 micro. And find the inductive and capacitive resistance. All right, so we're trying to find the first, for part D, we're trying to find the inductive and capacitive reactances. And so for part D, we have a couple things right now. Let's just draw our little diagram again. So let's just do that. Do this quick little diagram. All right, so we have a resistance of 275 ohms. So R equals 275 ohms. We have an inductance of 82.3, and a capacitance of 1.10. C equals 1.10 micro. And find the inductive and capacitive resistance. So let's write this down. So to find the inductive and capacitive resistances, all we have to do is for inductive reactances, it's XL pretty much equals WL, and for W, which is the angular frequency, is W equals 1.3 times 10 to the power of 3 radians a second. And for the capacitive reactances, it's going to equal pretty much 1 over the frequency capacitance. All right, so we pretty much just have to write it down, simply put everything in. So for our inductive reactances, let's do 1300 radians a second. That's what it would be if we spread it out. And it would also be 0.0823H. We multiply together, we pretty much get a resistance of 107 ohms. All right, for XL. And for the capacitive reactance, that'll just be 1 over pretty much 1300 again, radians a second. And just spread this out. It'll also be really small numbers, so 1.10 times 10 to the power of negative 6 F, which will in turn equal about 699.3 ohms of resistance for XC. So that's for part A. Now it's asking to find the phase angle. All right. So, I mean, to find pretty much the phase angle, we have to use this formula, which is going to be, let me do this real quick. So, tan angle, the angle would be the phase angle, and that would equal WL minus 1 over WC over R, which we already have WL over minus 1 over WC, which is just our inductive and capacitive resistance. So all we have to do is just plug everything. We already have our other resistance, so just plug it in. That'll be, this is XL, and that's XC right here. So just plug it in. That'll be 107 minus 699, pretty much 0.3 ohms over 275 ohms. This is about like negative 2.15. And then all we have to do, since we get negative 2.15 from tan angle to that, all we have to do is use like pretty much arctan to get the phase angle. So to get the angle, right here, we just go equals arctan negative 2.15, which is equal to a phase angle of negative 65.1 degrees. All right, so that was for E, and now we just have to find the power factor. The power factor is gonna be pretty much the cos angle. So cos with the power angle, the phase angle, I mean, and which is just simply cos negative 65.1, which is just equal to 0.421 for E, part F, I mean. All right, 0.421 for the power factor, F. All right, let's move on to the next question, which is going to be part G. And it's going to use the same questions, well, the same information we had from the last three. So for part G to I, it says, for the circuit in the preceding problem, find the impedance. So to find the impedance, we have to use pretty much this formula, which is Z equals R squared plus inductive and minus capacitive resistance over 2. So Z equals, let's just plug everything in now. And Z is the impedance. 275 ohms of resistance plus the 107. Oops, let me put that over here. 107 ohms. And what was it again? Minus. Let's look that check real quick. 699.3. 699.3 ohms of resistance, the capacitance resistance to the power of 2. Plug everything in, we will get an impedance of 653 ohms. All right. Now it's asking for in part H, for the circuit in the preceding problem, find the current amplitude. All right. To find the current amplitude, it's pretty easy. All we really have to do is use our previous information, because all we have to do is plug in these. V equals IZ, which is our current, voltage, and amplitude. Move I over here, equals V over Z. All right. We grab our volts that we have. Where did I put my volts? Real quick. Did I write it down? I didn't write it down. So we have, let me write it down here. So the voltage amplitude, it says we have of 35 volts. That is our I equals. All right. 35 volts. Plug it in. So that'll be our 35V over 653 ohms equals our current. And all we have to do is plug it in. So I equals 0.0. You know what? Let me not write it like that. It'll be 53.6 milliamps. All right, and it's asking again for the circuit in the preceding problem, find the average power delivered to the resistor. So the average power would simply just be pretty simple. Just plug everything in to this formula. So our average power would be equal to 1/2 of voltage and current multiplied to cos phase angle. We have everything already, so just plug everything in. That'll be 1/2 of 53.6 milliamps, which actually, let me just write it normally then, which would be 0. Wait, actually, hold up. Mess it up. 35 volts first. 35 volts. And now we put the current, which is 0.0536 amps. And then we multiply by cosine 65.1 negative phase angle. And all we have to do is plug it in. We get an average power of PV equals 0.395 watts. All right. So now we go to J2K. Let's just separate this real quick. I'll write it down like that. Let me move it over here. So J through L. And so the last three parts, and they're unrelated to the others. So the power factor of an LRC series circuit is 0.8. So let me just write that down. Just put PF. PF equals 0.8. The angular frequency is 1.3 times 10 to the power of 4 radians per second. So we write this down. 1.3 times 10 to the power of 4 radians per second. And the inductance is 7.5 milli-H. So that'll be, write that down, L equals 7.5 mH. The capacitance is, let's write it down over here, 0.4 micro F. 44 micro F. So let's put it F. Let's write down the little diagram that we have for AC currents and just doot. There we go. All right, find the inductive and capacitive reactances. Again, we've done this before. Let's see if we have to do anything different. Doesn't really seem like it. So let's just put our little formulas down. XL equals WL and XC equals 1 over WC. So plug everything in. All we have to do is put in, let me put this as W equals, let's put this as C equals, and then this is going to be resistance, this is C, this is L, and okay, so 1.3 times 10 to the power of 4 radians a second times, which would be 0.075. So 1, 2, 3, 75. And that'll be equaling to 97.5 ohms, which is equal to XL. And now we do XC for capacitive resistance. So that'll be, real quick, write that down here, 1 over, let's write it down properly, 1.3 times 10 to the power of 4. And that's going to be over again. What was it again? 0.44 times 10 to the power of negative 6 F. I don't have to write that down. Do that, which will equal an ohmage of 175 ohms. There we go. And so, yep, that is for part J. So XL, XC, capacitive, inductive, and capacitive reactance is right here. And now for part K, we have to find the phase angle. All right, so we already have the power factor. Since we have the power factor, all we have to do is just arc cos it. So we have cos angle equals PF. Our PF equals pretty much 0.8. All right, so all we have to do is plug into arc cos. So arc cos 0.8 we'll get an angle of 36.9. But since we have, what was it again? Higher capacitance of resistance, it's going to be a negative net resistance. So it's going to be negative angle, phase angle. Negative 36.9 degrees. All right. So pretty much negative net resistance. So that's the phase angle. Negative 36.9 for part K. Now, one last part is asking for finding the resistance. All right. So all we have to do to find the resistance is use this formula. So tan phase angle equals XL minus XC. It's the same formula as this one over here that we used before, where it's WL minus 1 over negative minus 1 over WC. Just simplifying it to our resistances of inductive and capacitance. And what was it again? We put resistance here. Since we're just finding resistance, all we have to do is put R by itself. To get R by itself, we pretty much just put it right over here. R equals, not there. Okay, R equals XL minus XC over tan phase angle. So we have everything in, we just plug it all in. Let's just plug it all in over here. So let's see. How do we write this down? Okay. So 97.5 ohms minus 175 ohms over tan, what was it again? Negative 36.9 degrees. There it is. Now we plug it all in, and we simply just get a resistance of 103 ohms. All right. That's for part L, which is the last part. And so if you want, I could just plug everything in. This is like 7.5 mH over here. C equals 0.44 micro F, and resistance is 103 ohms. And there we go. So I did all the parts for it. That was the last part, part L. And that should be for my exam. Thank you for watching.